Hi, in this video, pag-usapan natin ang geometric sequences. So, tapos na natin ang arithmetic sequences and arithmetic series. If you were not able to watch that video, you can review those videos or watch those videos. That's a separate video for arithmetic sequence and arithmetic series. So at the end of this lesson, students should be able to correctly describe geometric sequences. Ano ba ang geometric sequences? How is it different from arithmetic sequences? And properly distinguish the difference between finite and infinite geometric sequence. Correctly derive the formula for finding the nth term of the geometric sequence. And accurately solve word problems involving geometric sequences. So these are the questions that we want to answer at the end of the lesson. So how does geometric sequence differ from arithmetic sequence? How will you derive the formula for finding the nth term of a geometric sequence? How will you obtain the nth term of a geometric sequence? And how will you solve problems involving geometric sequences? So a geometric sequence is a sequence in which each term is obtained by multiplying the preceding term by a common multiplier, which we call common ratio. Common ratio denoted by R. So the sequence 2, 10, 50, 250, and so on. It is a geometric sequence whose first term is 2. And the second term is found by multiplying the first term by 5. So that's 2 times 5, and so we have here 10. 10 is the second term. The third term by multiplying the second term by 5, so that's 10 times 5, and we have 50 as our third term, and so on. So the common ratio is a constant term multiplied to every term of a geometric sequence to get the next term. It is found by dividing any term, except the first term, by the previous term. So we divide, let's say, for this example, 2, 6, 18, 54, we divide 6 by the previous term, which is 2. So that's the common ratio R, small letter r, is equal to 6 divided by 2, and that is 3. So the common ratio is 3. Similarly, you can also use the third term and divide it by the previous term, which is 6. So we have 18 divided by 6, and so you still have 3. 54 divided by 18, and that is also 3. Common nga, diba? So if a sequence do not have a common ratio, then that sequence is not a geometric sequence. How is a geometric sequence different from arithmetic sequence? So for arithmetic sequence, we have a common difference denoted by D. And for the geometric sequence, we have a common ratio. Okay? So, for example, for the sequence 4, 9, 14, 19, we know that this is an example of an arithmetic sequence because the common difference is 9 minus 4, that is 5. 14 minus 9, that's 5. 19 minus 4, that's also 5. So this sequence has a common difference. So it is called arithmetic sequence. However, for geometric sequence, example 2, 6, 18, 54. And so if we subtract 6 and 2, so 6 minus 2, that's 4. 18 minus 6, that's 12. Not a common difference. Okay? However, if we divide 6 by 2, so we get 3. 18 divided by 6, that's also 3. 54 divided by 18, that is also 3. So there is a common ratio. So this sequence is a geometric sequence. Again, pag common difference, that's arithmetic. Common ratio, it's geometric. So we have two kinds of geometric sequence. We have finite geometric sequence and we have the infinite geometric sequence. A geometric sequence is called finite if there is a fixed number of terms. Okay? So geometric sequence whose number of terms is finite. Example, the sequence 3, 12, 48, 192, 768, 3072 is a finite geometric sequence since the number of terms is 6 and it stops here. Wala tayong ellipsis dots na nakikita after the last term here. Okay? So meaning, since walang ellipsis dyan, or walang ellipsis dots, meaning this sequence stops at 3072 and this is the last term. So kapag ang geometric sequence ay may last term, then that sequence is called a finite geometric sequence. For the infinite geometric sequence, it is a geometric sequence whose number of terms is not finite. So wala siyang last term. It goes on and on. The symbol 3 dots or ellipsis dots is used to denote that the sequence has more terms. It goes on and on forever. Forever. Mabuti pa yung sequence may forever. Oh, di ba? So the sequence 1, 4, 16, 64, and so on is an infinite geometric sequence whose first term is 1 and common ratio is 4. Wait lang. Paano nakuha ang common ratio nga? We have 4 divided by 1, that is 4. Or you can also use 16 divided by 4, that's also 4. Or 64 divided by 16, that's also 4. Okay? Ano bang last term nito? Walang last term. Kasi, take note, it has ellipsis dots at the end, meaning it goes on and on. So therefore, it's an infinite geometric sequence. To find the nth term of a geometric sequence, we use the formula a sub n equals a sub 1 times r raised to the power of n minus 1. Eto yan. Ano ba itong a sub n? Of course, that's the nth term. Ang a sub 1, that's the first term. Ang r is the common ratio. And the n is the term number. So if we are looking for the 10th term, so we are looking for a sub 10, and then the first term, the common ratio. So our n is 10. That's the 10th term. Example, which of the following sequences are geometric sequences? Letter A, we have 5, 8, 11, 14. Let's see. 8 divided by 5, it's 1 point something. 8 divided by 5 is 1.6. And so we have 11 divided by 8, 1.375. Oops, dito pa lang, hindi na sila magkapareho. Diba? So it's the ratio is not common. Walang common ratio. No common ratio. Therefore, letter A, this one is not a geometric sequence. 10, 20, 40, 80. Let's see. 20 divided by 10, that's 2. 40 divided by 20, that's 2. 80 divided by 40, that's also 2. So therefore, there is a common ratio. And so therefore, this sequence is a geometric sequence. How about letter C? 9 divided by 2, that's 4.5. Okay. How about 16 divided by 9? That's 1.78. Oops, dito pa lang, hindi na sila common. Okay? So therefore, yung letter C is not a geometric sequence. Let's have example 2. What is the nth term of the sequence 2, 8, 32, and so on? When we say nth term, we are looking for the general term. Okay, the general formula. So we have, the first term is 2, and the ratio is 8 divided by 2, that is 4. 32 divided by 8, that's also 4. So the common ratio is 4. And therefore, this sequence, we are sure that this sequence is a geometric sequence. So, we are going to use this formula. Substituting, we are looking for this, a sub n. Substituting, our a sub 1 is 2. The common ratio is 4. And so we have n minus 1. So therefore, this is the general formula. a sub n equals 2 times 4 raised to the power of n minus 1. Another example. What is the 8th term of the geometric sequence 2, 10, 50, 250, and so on? We are looking for the 8th term, so that's a sub 8. First, sabi na dito geometric sequence na siya. So, no need to solve for the ratio of, no need to solve for the ratio of this, and that. Okay? So, we are going to solve just one ratio. So, that's 10 divided by 2. Yung pinakasimple, the easiest. So, 10 divided by 2, that gives us 5. And so, the first term is 2. And the n is 8. The n is 8 because we are looking for the 8th term. We are looking for a sub 8. Substituting the formula, so that's a sub 8 equals 2. That's the first term. R is 5 times 5 raised to the power of n. That's 8 minus 1. Always minus 1. And so 8 minus 1 is 7. So we have 2 times 5 raised to 7. So we solve this. You may solve this, all of this, using your calculator. But you may have this step by step, one by one. So 5 to the power of 7 first. So you have 2 times 78,125. And so that is 156,250. Therefore, the 8th term is 156,250. Example number 4. During an initial phase of an outbreak of measles, the number of infections can grow geometrically. If there were 4, 8, 16, and so on the first 3 days of an outbreak of measles, how many will be infected on the 6th day? Sige daw, during an initial phase, outbreak tayo ng measles. So, nung day 1, 4. Nung day 2, 8. Nung day 3, 16, and so on. So, sabi, ang tanong, how many will be infected on day 6? Okay. Solution, our first term is 4. Our n is 6 because we are looking for the number of infected on the 6th day. So, n is 6. Our common ratio is 8 divided by 4. That's 2. Okay. And so, substituting this formula, we have a sub 6 equals 4. That's a sub 1. Common ratio is 2. And then n is 6. So, 6 minus 1. So, 6 minus 1 is 7. 6 minus 1 is 5. 5, and so we have 2 to the power of 5. That's 32. 32 times 4. So, you have 128. Therefore, on day 6, there will be 128 people infected with measles. Okay, so I want you to copy and answer this in your notebook. Answer the following. You have to show your solutions.